Okay, well, that was embarrassing. Here at Petabridge headquarters, I basically just experienced a total power failure on my system here. All right, let me check my bit rate. All right, looks like we're back to normal. Well, that was embarrassing, but you know what? Things happen. All right. Yeah, you can't be a computer scientist without taking some risks every now and then. So, oh, my music's not playing. Let me fix that. Okay. Desktop audio. Okay. Can you guys hear the music playing in the background? I'm trying to see if that's back up and running again. My poor little computer. I guess I really need to change the dust on it. Let me go ahead and start running our actor spawn benchmark so that's going. All right. Audio. Okay. All right. Hopefully my little soundtrack by Twitch is playing here. Ah. I might have to go ahead and restart that. Yeah, it looks like it's working. Woof. Man, that definitely did some damage. Let's see. Go ahead and get rid of that. Okay. Yeah, it doesn't sound to me like you guys are getting music. Let me go ahead and relaunch Soundtrack by Twitch here and get that up and running. I don't want you guys to miss out on the chilled electronic. Although I really liked the previous track that we had. Yeah, man, desktop audio is really not cooperating. All right. There we go. I just had to pick the decibel meter up a little bit. All right, I'm a doofus. All right. There we go. That should be going through now. Okay. So, total actor memory footprint allocated 638 megs. And let's see, where were we? We had just tried messing around with weak references in here. I don't think that spawn benchmark will necessarily capture that. Reason being is that all those actors are still alive. So nothing will get garbage collected. So let me go ahead and try doing this. Let me open up a new tab. Commander here. All right. Olympus. No. All right. NuGet. Go ahead and try making a little beta build of Akka.net, and I'll try installing it into my other little code sample that I had running here. Fire this up. All right, that's Akka.net. That's my blog. That's my cluster workshop I'm working on. Here we go. Why don't we do this? New file. And let me go ahead and grab a NuGet.config that I can use. Usually keep one in this project. Yeah, there we go. All right. We'll go ahead and call this local. And then have a folder that I can get access to. Go ahead. Grab that. Whoops. All right, here we go. This is my little local NuGet folder that I keep on my machine. All right. I might turn the music volume down a little bit. I'm also not a huge fan of this track. For some reason, it reminds me of 1990s jock jams for some reason. All right. There we go. Let me go ahead and add path to this folder here. All right. Now, this should finish building in not too long. We have to build like 80 projects or something ridiculous like that. So we'll go ahead and give that a shot once that's finished. Let's see. Go ahead and minimize that. All right. And we'll stick this back over here. Now, Arjun, did you get a chance to see this pull request that we merged in? I think we merged this in last night. This is what we did on Tuesday night stream, where we actually rewrote the URI.try parse code inside ActorPath. So we're able to get the performance from, if I scroll down to the bottom here. Oh, you did watch the stream. Okay, cool. Yeah, I'm glad you liked it. We went ahead and did some final cleanup on this last night and got that merged in. So that improved the total performance of Akka.remote by a pretty tremendous amount. Let's see. Yeah, here we go. It went from going about 85,000 messages a second up to 107,000 over a single connection. Yeah, that stuff was not as easy as it looked. All right, here we go. Let's see. Looks like it's publishing the multi-node test runner first, which is always a pain. Well, Stream.create is around, but it doesn't. It's not supported in .NET Standard 2.0, so we can't even use it yet. I'd love to. That'd cut down allocations even more, but we don't have access to it. So I still have on my gist on GitHub my span hacks class, which is where I added like parsing for integers and all that sort of stuff on there. Okay, here we go. Now we're finally going to get our NuGet packages. All right. There we go. They really want us to go and incorporate our package icons and our licenses directly into the text of our NuGet packages now. So that's something that we're probably going to have to do. They've been giving me a warning about the license stuff for like 2 years. They don't want people to be able to just post a hyperlink to it anymore. For obvious reasons. It's to help avoid bait and switch. So if someone changes a license on an open source project after you've already using it, you're still stuck on what the license terms were at the time you installed it. So, useful to help go ahead and make sure you don't get taken advantage of by people who build popular projects and then decide to change to a more aggressive type of licensing in order to sell you a commercial version, or in some cases just poisoning the well because they don't want to maintain that package anymore. All right. Hey, another subscriber, Meta Info. Thank you. Appreciate that. Happy to have you. All right, this should be almost done. We can go ahead and test to see if that weak reference we added does anything. My guess is only destruction will follow, but, we'll find out. Okay, we're really trying to pack NuGet packages for aka.docs.tutorials. I should probably mark that as a do not pack package there. Jeez. All right. All right, guys. Almost done here. The one bummer about doing a stream during the day is I can't drink bourbon. That's what I appreciate about doing my streams late at night normally. Get to have my after work drink. Okay, there we go. All done with that. Now I'll go to aka.net, show and explore. There we go. And I believe all of our output is here. We're going to copy that. Bring that over to my NuGet folder here. Oh, you know what? I did one more thing. I got to open this up. My NuGet.config file I just wrote, I actually need to move it. Need to put it in here. There we go. Okay. Now next, I'll get rid of that. We'll go ahead and do 2.1 beta star. Use the latest version. Sure, we'll go ahead and restore those. And then let me grab another shell here. All right. Repositories. All right. CD. Actually, I guess I can just do this. And then let me grab .memory. Hoping I don't frag my power supply again on the stream here. I think I've got some dust bunnies in there I need to go clear out. Alrighty. That's all compiled. Oh, good. Well, thanks. Well, I was doing that on the fly. I actually, the sort of dabbling I've done here was really my kind of first foray into spanification. It was really Gregorius on the Petabridge / Aka.net team who kind of led the way on that stuff. He was able to speed up our murmur hash implementation we use for consistent hash routing by just like not copying the string we're hashing to a character buffer. He just spanified it, and that like reduced the amount of memory that distributed data uses by a huge amount. In fact, that's what he's working on today, is a whole bunch of distributed data memory optimization. All right, let's run this and see what happens this time. All right. Why does my computer still feel like it's barely waking up here after that restart? All right, there we go. Heap generation. See it kind of jumping all over the place. Well, I'm not seeing any errors getting thrown. That's not a bad sign. Some big peaks and valleys there. And now we should be entering steady state now. And yeah, it looks to me like it didn't really make much of a difference. So I'll go ahead and undo that weak reference change just because I'm going to use the precautionary principle here. So let me go ahead and discard the changes we made to that. Cautionary principle is, unless you can prove it doesn't do harm, don't change it. Oh, Mr. Souls, Mr. Two Souls, thank you for following me. I appreciate that. All right. I think I'm here. In core, Akka, children container, internal. All right. And I'm going to go back to child container base. And I got to move this class out. Oops. Missed a bracket there. All right, there we go. Move that out. And we'll mark this as internal rather than private. Okay. That should all work. All right, now I'll go to non-root normal child container. That all looks fine. Swell. Yep, so want to go ahead and defer the execution of that link query, so that's a good thing. That looks fine. Children containers shall die. All right, let me see if I can remember what we did here. And that down below. Go look for shall die. Oh. All right, well, that's pretty easy. No override there. You know, that was the thing. Okay. That was the thing I feel like I should look at. Although, nah, never mind. I thought we needed to go ahead and do an explicit add call, which would fail if we tried to add the same actor twice, but we don't need to. We take care of that in reserve. Return. Nope. We're going to go ahead and return this. We're going to do that. After actor stats name. And the data type we want to use. Where was that? Child name reserved instance. All right. Got that. I guess I need to convert this to an immutable dictionary in order to make the terminating child container happy. So we do have to make a copy there. That's not the end of the world. That's also not where the memory pressure is coming from. It's coming from spawning children. Unreserve. Okay. Wait a minute. If we tried doing unreserve, we go ahead and we return a mutable copy here. Is that just used during testing or what? Because we have a mutable method already inside our normal child container collection. That's a bit, that's a little sketchy. Oh, no. We do this, I see. We do this if it's, we return this only if it's a no-op. I got it. Okay. Alright, that's fine. I got it. I got excited for a second. Okay. Go ahead and do active stats. Okay, there we go. Now, is terminating and all that jazz. I believe we can return false on that. Let's take a look. Man, this is so old school. Some of this syntax. This is like before we had arrow functions on properties and all that stuff. And then let's give this a try. That contains method. Yeah, I guess we just use a little discard operator there. All right. That looks good to me. Okay. We got our little data structure now. Now we got to figure out when we're going to use it. Okay. So, go back to actorcell.children. I'm going to clean this up. Fail to modify documents. That's good. All right. Well, I don't know what's going on there. Resharper is letting me down. I have a meeting on my calendar, but I'm not actually going to be able to make the other person who's attending it, my wife, is not going to be able to make it. So we're going to have to do that some other time. Let's see. Immutable interlocked. All right. Whatever that is. Let's see. Where do we set this? Empty children container.instance. And is there a method in here? See, I had a feeling this is what was going on. Okay. Well, all this code we have in here does have some problems. Not the least of which is that all that compare and swap stuff will never evaluate now. Swap children ref. Unreserved child. Let's take a look at something real fast. Attach child. Let's see, I need to take a look at how our Guardian actors do this versus everybody else. Let's take a look. Internal actor ref, it's a temp container. Actually, you know what? Right place for me to look at this is the local actor ref provider. All right. All right, supervisor. If async, return repointable actor reference. I believe these are our top level actors. If we're a local actor reference, we can just go ahead and pass it through. So if I take a look at where this method gets called, come on, Visual Studio. All right, let's if I go to, let's say, actors system.children, and this is mate child, this gets called async. Actor of is async is false. Okay. So if I tell an actor cell to go ahead and make a child, that's always false. Got it. Okay. What are the conditions under which this method gets called when async is true? I believe it's only when the actor system calls it. Yeah, let's take a look. Yeah, let's go to implementation. Yeah, here we go. If guardian props is empty, do this. Attach child props. So basically, it's when we create system actors and top level actors is when we have to go ahead. This is the async part right here is when we do this. Yeah. So when we go ahead and call attach child, async is true for that. And this only gets called from the top level actor hierarchy. Yeah. Attach child only gets called inside when we're making top level actors, which is what the materializer is doing right here, or when the actor system is responsible for creating new top level actors. Okay. So when this happens, when a child is asynchronous, let's see. Attach child, guardian. That's a local actor reference. So if I go back to my actor ref provider, I believe the difference is the type of actor reference we create. We go ahead and create this repointable actor reference that gets created, and then we have to call initialize. Whereas this actor just initializes right away via its constructor. And that's because the other actor, the local actor ref, can be initialized inside an actor context. Yeah. So here we go down here. We have to go and start the actor cell. But it's not the child's actor cell. That's the problem. It's the parents. Okay. Swap underlying. Supervisor dot send system message. If async point. Turn this. Okay. All right, this makes sense to me. So, I think what I need to do to figure out if I can use my mutable collection here, we basically need to just not be running inside the Guardian. So let's take a look at actor cell.children. All right. Private volatile children container equals empty children container dot instance. Okay. Here's something I can do. So I can go ahead and subclass this too. Ugh. All right. Well, I guess we don't really need to do this, but that's okay. Go ahead and copy all that. Trying to do this without modifying public API signatures. So I'm going to do a little bit of copying. It's lesser of two evils. All right, and we're going to go ahead and call this empty non-root. Okay. This is an experiment, so we can always try to clean this up later. Okay, well, fine, I guess. But I really want to change. Here we go. Yeah, to hell with that. There we go. Looks good to me. Okay. That should be good. Other thing I got to do to make this work is we got to swap this out. So we grab that. Okay, and let's go to the actor cell constructor, which should be here. Root Guardian actor ref. All right. All right, that should do it. But let me go ahead and double check that the Root Guardian ref does what I think it does. It may not. I get the feeling this is the actor that's even above the Root and System Guardians. All right. Ah, shit. Yes, it is. Okay. System Guardian. Yeah, System Guardian and Guardian. They're both local actor references. Okay, fine. So that check, that would have been easy, but that's not going to work. This will add some overhead every time we start an actor cell, but this is pretty minuscule compared to what we're going to save. So let me take a look. Oh, you know what? If the parent's the Root Guardian, we can do it. Let's give this a try. Let me go ahead and start up a really simple code sample just to illustrate. Examples. Do you have any that don't use like Akka.remote? I think we've got a bunch of old ones that we haven't converted yet. All right, what type of actors do we create? Service hasher actor. Well, this would be more fun if I could have a little hierarchy of actors. Hey, sorry, my cat is awake now and has decided that chewing on my audio cables seems like a good course of action. Blissfully unaware of the electricity problems we've been having around here lately. Hey, cut that out, buddy. All right. Well, yeah, to hell with it. I'll go ahead and give this one a shot. All right, so startup project. Let's just see if this works. All right. You enjoying chewing those cables? Those good? Cluster system. Parent is the root guardian supervisor. Ah. Well, actually, maybe that's okay. All right. Let's give that another shot. All right, that looks promising. Good. Now, we haven't touched any of the compare and swap codes, so there's a fantastic chance we could end up running into... Okay, so who am I right now? Parent self is a logging actor. Okay, perfect. Yep. Specified method is not supported. Oh, no. I know why this happened. I know what happened here. All right, let me go ahead and change this. I know what this. I know what caused this. Let's see. It's because my dictionary, my little I dictionary right here, had an immutable dictionary, and those properties aren't directly assignable. So I need to go ahead and call to dictionary to turn this back into a good old-fashioned mutable dictionary. In fact, might just be easier. I went ahead and did var dictionary, string, dictionary name. There we go. And I can just pass that in. All right, we'll go ahead and use a little collection initializer here. All right, there we go. Yeah, full screen mode. All right, start running that again. Yep. All right. Okay. Well, I think we've established that this works. Is this a breakpoint? Yes, it is. Okay. All right, our clustering system appears to be up and running. Well, that's fantastic news. So I couldn't have broken anything too badly. That still works. So, yeah, that's normal. That's because I aborted the process. All right, that's looking good. In this case, let's go ahead and try a new spawn benchmark. So let's go ahead and commit our work so far. Let me get rid of some of this junk here. Added mutable child container for non-root objects. All right. Up. You know what? GPG. Never mind. There we go. It started up. Perfect. I was about to say the GPG agent may not actually be running on this computer since I had to restart it. But it looks like it booted up on its own. Okay. Okie dokie. Publish that. Our actor spawn benchmark. Got some data from it here. Let me go ahead, create a little pull request so I can capture some of this data. Mark this as a draft. Mark it as work in progress. All right. Draft that pull request. This will also kick off the test suite. So if I seriously damage anything, it should still keep going. Oops, I accidentally launched Slack there. That's okay. All right. Let's go ahead and run this again. So we allocated 638 megabytes last time in order to spawn 100,000 actors. I actually think that's not 100% accurate because that spawn benchmark's doing some other things behind the scenes. But we'll find out. I'll put it this way. My other benchmark launched 600,000 and it took about 100 megs of RAM to do that. Let's see. I want spawn actor benchmarks. Let's run that. And if this goes well, I'll go ahead and kick off a new NuGet package of Aki.net, and we'll go ahead and measure. The performance impact of these changes on basically the amount of garbage collection that's happening. All right. So this is taking about 1.5 seconds per operation. We were doing about 2.5 seconds per operation last time. So switching from an immutable data structure to a mutable one might have very well sped this up by quite a bit. All right, those are just warm-ups though. So that's basically forcing the jitter to go and optimize everything, which is what you'd expect in a busy system. You don't really care about performance in systems that aren't busy. So that's why you want to get JIT optimization factored in there. Now, the fact that this thing isn't completely crashing and burning gives me some hope as well. That's good stuff. But speeding up the actor allocation rate by a significant amount would be very nice. Now, the test suite will tell us if we screwed up in a way where we made it unsafe. Okay, check that out. So we reduced the total amount of time this took by 1.4, well, basically by about a second. And we reduced the amount of memory we allocated by, let's see, what was the previous number? 638. So that's about 200 megabytes that we've improved there. So let me go ahead and grab that value. Guess I'll use this to get it. That's pretty impressive. That's a good... I suspected, I've known for years we could do that. Well, this is my first time actually trying it out, though. But that's a pretty significant improvement. After creating a mutable. That looks pretty good. That is excellent. 437 megs. All right, now the next thing we can do to go ahead and try to mess around with this. Well, let me go ahead and kick off a NuGet build behind the scenes. Arjun, what do you think of that number if you're still watching? Uh-oh. Gonna lock up Visual Studio now that I'm working on this again. Yeah, pretty good. I think so too. Alright, well, Visual Studio is going to have some trouble while the build system is running. So let me go ahead and grab VS Code here. Open that up. Less memory. We also improved the spawn rate by quite a bit. That's another encouraging sign. Now, next thing we can do, if we feel like trying to go even further with this, let's go ahead and take a look at... Now, we shouldn't get too excited because I'm sure the build system... Yeah, exactly. So a lot less stuff made it into Generation 2. Basically, because we're not creating new copies of those dictionaries anymore, we are allocating many fewer objects. So we're able to get away with it because actor creation and all these other parts of the hierarchy is safe. It's not safe in those guardian actors, but it's safe everywhere else. So if I go and take a look at, let's see, I wanted to grab core Akka. Here we go. Want to take a look at actor, children container, child stats. Let's see. Now, what else could we do? Child.path.uid. Well, I could definitely modernize a bunch of that stuff that's in there. Let's see. I was tempted to turn this into a struct. But I don't know if that would help necessarily. So that's one thing we look at. I need to take a look to see if there's any equality by value stuff going on with this. I don't think there is, but nevertheless. You know what? Maybe it can't hurt. All right, looks like we're almost done making those NuGet packages. So I can run my .memory test again. Struct. Yeah. Missing command. I don't know what that's about. We'll give that a try next. Pack failed. Oh. Well, this is because I modified that code in the middle of compilation. That's all right. If as long as my Akka NuGet package is in here, which it's not. Okay, well that's a pisser. Guess I shouldn't. This is what I get for trying to do multiple things at once. Let's discard that. Well, maybe not. Yeah, maybe not. Let's take a look at internal. There we go, child stats. I hate having all these TBD comments around. Would have been better off just without any XML dot comments than to have that. Okay. Okay. Yeah, I can clean that up some other time. All right, so what's wrong with turning this into a struct? Sure, it has to do with the constructor arguments. Well, someone used GoStock on Akka.net a long time ago. Oh. That's part of the issue. We're using null, so I can't do that. That's too bad. Null ability wins again. All right. Yeah, ghost doc is like if you hate your other co-maintainers, use ghost doc. Goes and generates a bunch of XML doc comments that have zero value at all. Okay, well, I don't think there's much else I can do to try to improve the memory performance on the child container stuff so far. Let's take a look at the actual methods that are using it, though. Maybe there's something we can do there. Let's see. Let's clean that up. Failed to modify documents. Same problem we had as before. Okay. Uh-huh. Stop. It's really when we're creating children. This is where we create the new child actor. Reserved child. Unreserved child. Init child. That's fine. It's fine. That seems to all be working okay. Well, let's take a look at the new... Let's see. Well, in terms of making it faster to spawn child actors... Get rid of that. One thing I know we could do... Take a look at this. Validate. I think validate is safe. I don't think that should allocate, just iterating over the contents of the string like that. I think that's probably fine. I don't think converting it to a span will help there. At least I hope not. I think that should be okay. Well, one other thing I know we could do, if I take a look up here. So this method, get random actor name, is actually, believe it or not, deceptively expensive. And the reason why is because we go ahead and we create a brand new string builder, and we go ahead and we base 64 encode it, and then we call it to string on that. So if we're allocating a ton of actors really quickly, that could actually add up a little bit. So some things we can try doing to yield some additional performance here is actually pooling these string builders. Maybe we can go ahead and take a look at the base 64 encode method here. Yeah, get a load of this. We've got another version of this function right here that does the same thing, allocates a new string builder each time. Let's see. sb.append, base 64 chars. Doing some pretty fancy stuff here for base 64 encoding, but that's okay. It's another thing that we're doing. Okay. Well, why don't we do this? I'm going to create a new utility class inside Akka.net. I hate some of the namespaces on this stuff. There's so much crap in that utility folder I absolutely want to just get rid of. But first, I have to add something new to it. Let's go ahead and call this object pools. .cs. And then I'm trying to remember if I need to reference a NuGet package to do this. Why are we using string builder for this? Good question. We add a string builder. Do we even pre-allocate this? Next is this long value. Well, next does not equal 0. I mean, I'm guessing you could just predict the number of bytes you need to go ahead and base 64 encode this long integer, and you could just pre-allocate a span for that and return it. Well, actually, I guess you can't return a span because it's struct. It's a struct. But maybe you could. I'm not sure. But that is something we could get away with. Let's see. Let's take a look at this. We pass in a prefix to the string builder, then generate a random name. Wait a minute. Do we do this for every single actor cell? We have a unique long integer for all of them? Oh, I guess that makes some sense. That seems like kind of a waste, though. That's an extra, extra couple of bytes per actor that we probably don't even use for most of them. Yeah, that's all right. All right, string builder, prefix. Well, let's go ahead and try object pooling first. See if that can help. Okay. An array pool. Let's see, string builder. I think this is it. Let's go ahead and initialize that. Let's see. My guess is I have to use a factory method. It's an abstract type. Okay. Touche. That's shared rent. I get the feeling that array pool's the wrong type for this. So I'm going to go ahead and do a little bit of Googling. Yep. My instincts were correct. Microsoft.extensions.object pool. That's what I want. Well, maybe it'd be better if... Might be better if we just went ahead and try to predict how many characters we need to encode that string rather than doing this. That way we can go ahead and avoid the string builder altogether that way. That would probably not be a bad idea. But let's give this a try. So let me open up Akka. Pretty sure Andrew and the Akka.NET team's done a lot of work with this already, so he'll probably have some pointers on how we can do this better. Looks like we're referencing system.collections.immutable twice, so that's a bug. That's okay. Actually, how many versions of this NuGet package are there? Let's see. This is one of these ones that's always bumped every single time there's a new release of the framework. All right. Stick to using that. Okay. Actually, you know what? Grab this first. Reload. All right, let's give that a shot. Visual Studio does not like it when I update project references that way. Hope I didn't break anything. All right, there we go. Yeah, I appear to have just now lost a bunch of the code files that I had open as a result of that. Well, that's okay. Can I make an omelet without cracking a few eggs? All right. It looks like the solution's busy syncing itself. All right, get rid of you. Go away. Man, for a pretty powerful computer, I still have trouble loading Visual Studio solutions. All right. I'm guessing ReSharper and loading a 80 project solution has something to do with that. That's okay. Okay. I should be ready to go ahead and implement my object pool now. So I don't want to use an array pool. I want an object pool. Uh-oh. Yeah, that's right. All right. Using Microsoft.extensions.object pool. I gotta probably rebuild the cache here. I might have actually completely borked ReSharper. Never mind, there we go. Back to normal. All right. That's enough. All right. Object pool. Then I guess I got to actually go and allocate it. Cannot create an instance of that. Okay. Okay. You're going to show me how to use the object pool? I guess I got to specify default object pool. All right. There we go. And I need a pooled object policy. Maybe if I do default object pool provider. Hey, how about that? Let me do this. Actually, is there a whatever. Okay. Initial capacity, 10. Maximum retaining capacity, let's do 1,000. Okay. Give that a shot. And then the places we've been using String Builder. Let's go ahead and take a look at actorcell.children. Okay. I'll comment that out. Let me make sure before I keep going too far with this that Let me go ahead and commit these changes to child stats. Commit that real fast. Then I can work on messing around with object pools. Move that over here. All right. Push that up. Looks like we had some build failures. Let's take a look at that. Failing after 20 minutes, 14 minutes. Good chance a lot of these are just racy unit tests. But it can be difficult to tell. Let's take a look. Nope. These are definitely hard failures. Well, yeah, it's API approvals. Index out of range exception. All right, so yes, there's definitely some problems with the Aquastream's materializer and working with some of this code. So the changes we made are not free. In other words, we're going to have to take a little bit of a look at what's going on there. My guess is I'm missing a case where another actor is attaching itself to a container from the outside. It's probably the Aquastream's materializer. That'd be my guess. Okay. Yep. I'll go ahead and do... All right. Then... Oh, okay. All right. So I'll go ahead and do this. Actually, you know what? Rather than do a try catch block. Do this. SB. All right. Let's give that a try. Other place we can go ahead and do this. Where do we use this? Working with temporary actors. This is part of the overhead of the ask operation, is working with these. So, all right, fine. Gotta get rid of some of my cool syntax. All right. All right. Let's see how that goes. Run our actor spawn benchmark again. Okay. All right. 8. Yeah, let's see what happens with this. The end-to-end execution time numbers are starting to look even better. My guess is they'll be pretty close to what we had before, but still. All right. So we allocated 427 megabytes. Numbers from before. All right, so we shaved off another 10 megabytes from the benchmark by doing that. But this is and then let's see, what was the execution time? 1.47 before, and what's it now? 1.448. So we were able to go ahead and improve this a bit more by pooling those objects together. But we did that kind of at the cost of having to go ahead and introduce a new NuGet package dependency, etc. So the other thing I should measure actually is this should have pretty significantly improved the performance of the ask operation. So I'm going to go ahead and do, how should I do this? I guess I'll go ahead and commit this. Yeah, I'll go ahead and say pooling string builder. All right, push that up. Now, if I go check out our development branch real fast, I'm going to run this. Let's go ahead and set a baseline. We're working with the ask operation. Let's see. Actor selection benchmark, I think, is where this lives. Let me take a look. Yeah, it's the actor selection benchmark. Request response actor selection. All right, go ahead and restore some of that. Rid of that. All right, let's go ahead and run that. That's another area we could really easily performance optimize using spans is actor selection construction. That might be worth looking at. $100 milliseconds per operation. Oh, that's because we're doing like lots of iterations all at once. In fact, we're doing 100,000 or 10,000, excuse me. So 10,000 iterations in 100 milliseconds. I guess would mean that we're doing about one operation per microsecond. That's a million requests per second? Don't think so. That sounds a little high. I think the last time we benchmarked ask performance, it was like about half that. So we'll see when the results come in. But I have a little bit of trouble believing that number. That sounds a little high. Right, let me do a calculator. All right. Oh, it's because it was 10,000. Okay. So 100 milliseconds. Let's see. Every millisecond is 1,000 microseconds. So it's 100,000. Divide that by 10,000. All right. 10 microseconds per operation for ask on an actor selection. That's actually pretty awesome. That's definitely faster than I remember. We'll find out. All right. So request response. 10,000 iterations took roughly 100 milliseconds, allocated 20 megs of RAM. Okay. Let's go back to my branch I was working on. So actually, let me go ahead and save these numbers real quick. Grab these numbers in VS Code. And put it into a new document. Go ahead and discard all those. All right. Let's give this a try. Okay, let's see what impact not having to allocate a brand new string builder for every single temporary reactor may have had. Let's take a look at that. Now, I think the way I am going to go about optimizing that is I think I'm going to get rid of string builder altogether. Just try to predict how many bytes I need to go ahead and base 64 encode a long integer. Let's see. I would not expect this to make that much of a difference. Well, we'll see. I'm always skeptical. This, to me, actually looks like it may have slowed things down. So what we might see is a lower throughput, but also lower memory usage. So the actual cost of, let's say, getting stuff out of the object pool in terms of pure throughput might outweigh the memory benefits of doing that. That's sure what it looks like to me. But we should find out in just a moment. So yeah, I agree with you, Arjun. I don't think this should make that much of a difference. In fact, it looks like it had a negative impact on throughput overall. All right. This should be done in a moment. All right, this is a weird song. Okay. Benchmark is still running. It might be having trouble basically achieving the right type of like modal distribution. I had a problem with benchmark.net on last night's stream where it was running like nonstop for like 10 minutes without being able to produce a result. So I'll let that go ahead and ride for a second. Now, if we take a look at this code, this base 64 encoding, well, the maximum number of characters we could possibly need to do this. We'll just do the math out loud here. This is like one of those whiteboard developer math questions I should be able to answer. But I actually can't remember off the top of my head. Like for base 64 encoding, 64-bit integer, how many characters do you need? You know, how many 8-byte characters do you need to represent that? I'm thinking it's like no more than 4. But it actually depends on what the value. I think 4 is the maximum, but I should be able to answer that. But it goes to show you how reliant I am on looking up older ways of doing stuff to go ahead and figure this out. But that's probably the next thing we should try to do is get rid of the need to have a string builder altogether. Because in fact, I don't think there's any methods after this where they're doing anything other than just stringifying it. And let's see, is this static? Is this stuff all public? Okay, yeah, of course. Of course it is. Okay. What a bunch of crap. All right. Okay, let's see if this finished. All right, so here's the final result. We shaved off a megabyte, but we lost about 20% of our performance. So this is a scratch. We're going to go ahead and get rid of that commit. Not worth it. Now, we've got some problems with that child container collection by the sound of it. So one thing I'm going to do... One thing I'm going to go ahead and do is remove... I'm going to go ahead and basically create a new branch. We're going to go ahead and get rid of string builder from these methods. I think that's the way to go. So Visual Studio is trying to get its act together. While that's happening, I'm going to fire up LinkPad. We'll plan on wrapping this up in about 15 minutes or so. Sure. All right, so let me go ahead and grab this. Visual Studio is really struggling at the moment. All right, statements. Long value. Well, let's do this. All right, we'll go ahead and call this base 64 no SB. And then let me go ahead and create a little function out of what we had here. Yeah, let's grab this. All right. Oh, this will turn a string. Well, guess I have to make this a C# program. Down here. Base 64 chars I need. Whoops. Let's go grab this. In fact, just to be clean, I'll do it that way. All right, so go ahead and do val basic form code. Actually, you know what? Just to kind of preserve the behavior that we had. Okay. So our goal is to get rid of this string builder, go ahead and make it so this method doesn't allocate and can properly base 64 encode these values. So let's go ahead and take a look at our input. What I want to figure out first is what's the maximum size of one of these For storing, let's say, long max value or min value, what's the maximum output from a base 64 encoded function? I think it should be 4 bytes, but I am 4 bytes plus 1 byte for the prefix. But I want to go ahead and double check that. Prefix, we'll leave that as is. Then, you know what? Bar encoded equals, we'll go ahead and cache this. Not smart enough to figure out just by looking at the bit shifting that's going on. It's been a long time since we've had that in here. What the max size should be. Alright, that was good. Let's go ahead and run it. Extension methods must not be defined as a non-generic class. Whoops. I did not mean for that to be extension method anymore. That seems like it took a lot longer than it should. So that's a 12-character one. Insufficient memory to continue execution of the program. So I think working with a negative long integer may not even be supported by this, probably because of the bit shifting here. So if I change this to, let's say, just for argument's sake, a U long. Let's get a load of that. All right. Got it. Thank you. Okay. So the minimum value is 0. When I'm doing, an unsigned integer. So the maximum value is 12. If I go ahead and don't do a prefix, let's go ahead and say I do null. Is that still 12 or is that 11? It's 11 now. Okay. I should be able to swing that in that case. So about 11 characters to base 64 encode that. Just to double check my math to make sure our base 64 encoding function is actually doing its job. Let me go ahead and rely on good old Google here. Let's see, UTF encode each. Base 64 URL encode format. I'm just double checking my output. Well, I get something completely different than what that function does when I base 64 encode it. So I'm wondering if there might actually be a problem with our character array, because this doesn't make a lick of sense. That I'd get an output like this, which is kind of what I'd expect, versus getting this monstrosity down here. Let's see. Next equals value. Next equals next. Shift to the left. 6. Well, seems right. I wonder if we're missing characters in here. Let's see. You know what? Let me take a look at one other thing. Base 64 legal characters. All right. So for base 64 encoding, in terms of our legal... Man, there's a website for everything. All right, we'll go move this over here. So our whole array of all these base 64 encoded characters does not look right to me. Looks like the capitalized letter should come first. That's 1. Then you should have the digits. And then you should have a plus and a slash, not a tilde. Let's go ahead and change that around. Now I know why we probably did this. Oh, it's because it's not URI accessible. And we're casting this down to an integer in order to fit into the index here. That's probably part of my issue. is that we're probably losing some output here. Like if I go and do, well, I don't know. That's one of my values. I go and run it. I get something that makes a lot more sense to me down here. All right, well, no use crying over it. So I'll go ahead and flip that around. But I think that's what's going on. I think this integer truncation right here is creating some of the problem. Let's see. There's probably a better way of doing this using some bit shifting that doesn't result in loss. But we're not trying to actually uniquely base64 encode anything in here. We're just trying to generate a URI-friendly name. So let's go ahead and focus on the important part, which is the span bit. So we know that the largest possible, if I get rid of this, largest possible string we could take is 12 bytes. So why don't we do this? I'm going to go ahead and now if I wanted to be a smart computer scientist, I would go ahead and calculate based on this integer value how many bytes I'm going to need to represent that. Since I am not one of those, and I am in fact quite lazy, I'm going to go ahead and do stack alloc char 12. Maximum number of bytes we could possibly have. I'm going to stick this into a span. Now, I'm also going to go ahead and say, if prefix... Actually, if I really want to be clever... Yeah, guess what? New sheriff in town. Prefixes are characters. Deal with it. Alright. Actually, I guess I do kind of need a string there. If string is null or empty. Prefix. I really guess I should support a flexible amount of prefix there. Okay, fine. We'll do this. 11 plus prefix.length. God, that is ugly. Okay. Seriously, I hate nulls. Okay. If string is null or empty... and prefix dot length greater than 0. We'll go ahead and do prefix dot span copy to SB. And we'll go ahead and do let's see, span index. I'll go ahead and set this to 0 initially. Then I'll set this down here to, let's say span index prefix dot length. All right, that should do that. Rather than do this hunk of garbage, we'll go ahead and do SB span index equals then I'll go ahead and do a little plus plus after that. All right, here's our output from before. I'm gonna go ahead and copy that. Let's run it again. Forgot to do something important, which is we want to slice from 0 up to span index -1. I think. Output. Well, worked great for long stuff. For index, span index plus plus. Length equals 1. That didn't work either. Oh, I figured it out. I think. Prefix length, spanning x equals 1. All right, let's take a look at this. All right. Index. Next equals 0. All right, well, that figures. Span index is equal to 0. What's in my little span so far? Span index $A, which is right. Span index -1. Oh, that's not right either. All right, let's give that a try. Span index is now 2. $B, this looks right. Length equals 1. Oh, well, that's what I'm doing wrong. Is I'm computing this should be the length. Yeah, okay. In that case, it was actually probably fine the way I was doing it before. There we go. $A. Perfect. All right. $B. All right. Well, this looks like it's actually working out. Okay. That looks good. $A for a length of 2. Ah. Well, I forgot. If I go ahead and take a look up here. It looks like I accidentally got rid of one of my test values. This one. Give that a try. Get rid of that. NY. So mine came out a little different this time. Is it because I reversed these characters? Wonder if it is. Well, it's looking all right to me. I think it is. I think that's what happened, actually. All right, let's go ahead and give this a try. See how this impacts the performance. Man, that's brutal. Actually, you know what? Let's do this. There. Okay, let's see how this does. For actor selections. See if there's anything on the error list I need to worry about. Nah, just Visual Studio being eternally angry with me. Let me go ahead and just shut it down, actually. All right. We'll go ahead and run this, and we'll call it a day. Let's see. I'm going to go ahead and move my soundtrack over here. This is a song about Winona Ryder, apparently. All right. Let's go ahead and do actor selection. All right. All right, performance gods, be kind. Bestow your favor upon us. Sacrifice some scotch, it might help. I gotta go downstairs to get my scotch, unfortunately. But yes. The performance gods like it when I drink. Hey, look at that. We've reduced allocations by about the same amount we did before with object pooling, but we also actually significantly improved performance. Well, that makes me feel swell. All that. Good deal. So, let me go ahead and double check our change set here. So, making that call. Making this call. I think everything should be okay. Let me go ahead and check in the public API, because we did make some changes. Core akka.api.tests .NET test C release. Gotta spell release right. Framework net core app 3.1. Well, I'll keep trying to make the performance improvements work around that the actor container stuff, because I do think there's some benefits to that. I still need to go ahead and test it in my other piece of software. But this getting a chance to get rid of that really awful string builder stuff makes me very happy. All right. Well, you guys gonna let me, select this? Okay, there we go. Thank you. Appreciate that. All right. Now, if I rerun that, that should work. Okay. Perfect. All right. API is in good shape. Let me get rid of that. Removed string builder. Allocation from base 64. Okay. Go ahead, move it over here. All right. Well, that's a win. Apparently, I typed my GPG key incorrectly. All right, that's better. All right, wait for that to come in. All right, so let me go ahead and add my before. This also affects actor spawning, but the actor selection bit kind of shows the results pretty clearly. So this is my before value. This is my after value. Oh, you know what? I actually need to open that. This is my after value. Grand. We'll go ahead and call it perf. All right, and I'll tack this on to the 4121 milestone and go ahead and submit that pull request. All right. Well, that was good to me. I need to get someone to review that before it can get merged in. But we did reduce Gen 1 garbage collection quite a bit. That makes me very happy. And we were able to go ahead and improve throughput by, let's go ahead and call it 10% roughly. Slightly higher. It's more like, I guess, 11. But you know what? I'll take it either way. All right, everybody. Well, that'll do it for my stream today. Thank you very much for tuning in. And Arjun, thanks for chiming in, helping me out with all the troubleshooting here. I really appreciate it. Hope you all have a good weekend. And I will see you next Tuesday night, where I will go ahead and pick up where we left off and do a lot more performance tuning. So thank you very much. I appreciate it. Have a good weekend.